In this video, we're going to show you how to use a number of Excel functions to calculate normal probabilities. Let's start with the first case where we have a standard normal distribution. That means mean equal to 0 and standard deviation equal to 1. So what we have here is the graph of a normal distribution. As you can see that, let me just put this aside. As you can see that the mean and the mode and the median is at 0, and the standard deviation is equal to 1, which you cannot see from the graph. So in order for us to learn about using these functions, we need to look at the 5 different scenarios. The first scenario is to find the probability of a standard normal distribution that is less than a number. So probability of z less than negative 1.25 in this example. So the important thing for us is that we should always draw a graph to see what is it that we're looking for. So in this case, what we're looking for is the area that is less than negative 1.25, the probability of z less than negative 1.25. So that what we're looking for is basically this area. Now, in order for us to do that, that's actually pretty easy. So all we have to do is to use this function, right? So I'm going to spell this out for you. Is norm.s.dist. Actually, what we should do is actually just use norm.dist in order for us to learn it easily. And then we put the numbers that we're looking for into the functions, so negative 1.25. And in order for us to use this Excel function, we need to specify the mean and the standard deviation. So the mean in this case is 0, the standard deviation is equal to 1. And because of the fact that we're finding the area, not the value at 1.25, we're going to just put in the parameter 2. So in order for us to calculate this probability, all we have to do is to enter this function, okay? norm.dist, negative 1.25, the mean is equal to 0, standard deviation is equal to 1, and 2, right? So now let's just calculate this. I'm going to copy this, and then we can actually calculate the value here. And the value is equal to, and let's format this a little bit better. The value that we're looking for is 0.1056. So that's the first case. The first case is to look at the probability of less than. The second case is more than. So in the second case, we're looking for probability that z is bigger than a number. So in this example is 0.45. Again, if you draw a picture, this is very important for us to draw a picture. We can see that what we're looking for is this area, right? Z bigger than 0.45. 0.45 is around here. This is 0.5, so 0.55 is just a little bit less than 0.5. And what we're looking for is the area under the curve that is bigger. So we're looking for this area. Now, in order for us to do that, we cannot use this function directly. Instead, what we have to do is to calculate the area below, which is given by this function, and then 1 minus. So for bigger than, what we do is we do 1 minus norm.dist against the point that we want to find, which is 0.45, comma, the mean is 0, the standard deviation is equal to 1, and TRUE 2, right? So that's how we enter this function to find the value that we're looking for. Again, we can actually just copy this and calculate this value, and it's actually pretty straightforward, right? So again, we format this to 4 decimal places, which we should always do. We get 0.3264. Now, if you look at this graph, we kind of know that the answer is about right? Because the mean and the standard deviation, the mean of the normal distribution split the normal distribution into two equal parts. So the area of half of the distribution is 0.5. This is the lower half, this is the upper half. And the area that we're looking for is slightly less than half, upper half of the distribution. So it's less than 0.5. And so the answer that we found probably is right. Now, the third case is in between, right? So if the first case is less than, the second case is more than, and the third case is in between. So in this example, we want to find the probability that he said is less than greater than negative 0.65, less than 2.32. So what we're looking for, again, if we draw a picture, which we should always do, negative 0.65 is about here, right? Negative 0.65, this is 0.5, so negative 0.65 is about here, to 2.32. 2.32 is just a little bit less than 2.5. So what we're looking for is this area here, right? So this is the area that we're looking for. And that's the probability that we want to calculate. Now, if you draw a picture, you can actually see, in order for us to find this area, the best way to do it is to take the area from here to here, which is what is given by the function, minus this area, right? So in order for us to find the area in between, you take the biggest area minus the small area, you get the area in between. The big area, of course, is the function calculated at 2.32. The small area is the function calculated at negative 0.65. So if you want to write this out in Excel, what we can do is to say norm.dist bracket 2.32, comma, the mean is 0, standard deviation is equal to 1, TRUE. So that's the area. This is a big area from negative 0.32 all the way to negative infinity, minus the small area, which is norm.dist negative 0.65. The mean is equal to 0, standard deviation is equal to 1, and 2 is the parameter. Okay, so if we enter that, you can actually, let me just make it a little bit bigger. You can actually see, let me just make it a little bit bigger. And you can actually see the function that we want to calculate, right? So if you copy, again, we copy this part and we can just calculate this easily. And the answer, of course, is equal to 0.7320. So these are the three different scenarios for us to find probability if we are given the points: less than, more than, and in between. And these three cases represent all possible cases. Now, before we move on, I want to make sure that you know for a fact that there is another function that we can use to find the probability. The function is norm.s.dist, right? So if I actually enter, for the first case, norm.s.dist, this function represents a function to find probability when it's standard normal, right? So when mu is equal to 0, the mean is equal to 0, standard deviation is equal to 1, is called the standard normal distribution. So we can actually use this to find the standard normal distribution in this case. And because of it, we don't have to enter the mean and the standard deviation, because by definition, standard normal distribution has mean equal to 0 and standard deviation equal to 1, right? So all we have to do is just enter negative 1.25 and then 2, right? So this is another way of doing it. It's not the way that I prefer to do it because of the fact that we actually, I forgot to put comma here. We have to remember another function. Where is the function that we're using? Here, let's just forget about this one. The function that we're using here is applicable in all cases, okay? So again, let me just do it one more time when I can focus. So if you want to use a standard normal distribution function in Excel, is norm.s.dist, right? And you want to put in the point negative 1.25 in this case, comma, and it's either true or false. In this case, if you have so a little bit more decimal places, it should be the same. Okay, how come we're not getting the same? Okay, so we should get the same, right? So once we enter it properly, we should get the same. Okay, so you actually have a choice, but I would prefer that you always use norm.dist because it's uniform across all cases. All right. So if the first three cases represent the situation where you're given the point and you want to find probabilities, then the last two cases is the other way around. So in the last two cases, we're looking for a situation where we are given the probability, we want to find a point. That means if you're given an area, we want to find the point that corresponds to that area. So the fourth case that we want to present is this one. If probability of Z less than A is equal to a probability, what is the point that we're looking for? All right, so we're given the probability 0.26. We want to find what A is. Now, so again, if you draw a picture, what you can see that is that we are looking for the point A somewhere around here, where this area is equal to 0.26, right? This area represents the probability. So we're given the area equal to 0.26, we want to find this point. Now, by drawing this picture, that you know that A is a negative number, right? Because if A is positive, if A is positive somewhere around here, then this area is more than 0.5, right? Because half of the normal distribution is 0.5, but we only have 0.26. So A is actually somewhere around here, right? Because this is less than 0.5. So in order for us to do that, this is actually very simple. All we have to do is enter this Excel function, equal sign, norm, D-N-O-R-M, dot inv, right? So that's the Excel function, bracket, and then what you have to do is to enter the probability, the mean, and the standard deviation. So the probability is 0.26, the mean is 0, the standard deviation is equal to 1 because it's standard normal, and the number that we're looking for, again, if you look at just two decimal places, is negative 0.64 as we expect, right? So negative 0.64 is just a little bit around here. So A is this one. Now, let's do one more example. So suppose we want to find the area where the probability is 0.05. Now, this is a very important situation in the coming modules, because when we calculate confidence interval or in hypothesis testing, we always want to find a point that corresponds to probability equal 0.05 or 0.025. So let me just practice again. If we want to find the point that corresponds to the area 0.05, now 0.05 is a very small area, so we kind of know that the point is going to be much smaller, right? So how do we do that? We say equal sign norm dot inv 0.05, and because of the standard normal, so it's 0 and 1, right? Mean and the standard deviation, and the point that corresponds to is negative 1.64. Now, the other value that we always are looking for is actually when the area is equal to 0.025, right? So if the area is equal to 0.025, what is the point that corresponds to it? Again, let's do it the last time, is equal to norm.dist 0.025, 0, and 1. Okay, so what's wrong with that? Oh, sorry, we entered the wrong function. We should do norm.inv. Okay, and this number is negative 1.96. And you realize that this number is a number that we use quite a bit. So that's the fourth scenario. The fourth scenario is about given the probability, given the area, we want to find a point less than. So the last case is very similar to the fourth case, except that we're looking for the point when the area of more than that point is given, right? So in this case, we say find A if probability of Z bigger than A is equal to 0.0375. Bigger than A. So bigger than A is in the upper tail, and because of the fact that the number is less than 0.5, so A probably be somewhere around here. Okay. Now, do you have to know these things? No, you don't have to. You can just put it into the formula. But drawing the picture, getting to see what we are looking for, and get a sense of whether we are getting the right answer is actually very important, right? So in this case, can we find A directly? And the answer is no, because the functions all work with the lower tail, not the upper tail. We know the upper tail is equal to 0.375. If the upper tail is 0.375, what is the lower tail? The lower tail is 1 minus 0.375. So again, we use the same function, equal sign, norm.inv. Instead of putting negative, putting 0.375 into the function, we put 1 minus 0.375 into the function because we know the upper tail, but when we use a function, we need to put in the area of the lower tail. And then the mean is 0, standard deviation is equal to 1, and the answer is, again, if you just, because we are finding a point, just 2 decimal places, this answer is 0.32. So these are the 5 cases that we need to know when we use Excel function to find either the probabilities or the points for normal distribution. So we start with standard normal distribution when mean is equal to 0 and standard deviation is equal to 1. And the process that we learn is important later on when we try to use this for confidence interval or hypothesis testing situation. On the other hand, we also want to know what happens if we want to do the same, exactly the same thing when the distribution, the normal distribution, does not have a mean 0 and the standard deviation equal to 1. Well, the process is actually exactly the same, right? So let's just get to it, right? So in this case, suppose we have a normal distribution, the mean is equal to 50, the standard deviation is equal to 35. Again, we still have the same 5 cases. Let's see how we do it. Now, for the first one is less than, right? So again, it's important for us to draw a picture so that we can actually see what we're looking for. So what we're looking for is 43, right? So 43 is, let's make sure that we find it. 43 is around here, right? 43 is around here. And what are we looking for? We're looking for less than. So 43 is around here, and we're looking for less than, so the lower tail. So if it's lower tail, we just use the function directly, right? So we enter equal sign norm.dist 43. Right, so now in this case, the mean is equal to 50, so we put 50 in. The standard deviation is equal to 35, so we put 35 in, and the last argument is always true. Okay, so this is how you enter the Excel function in order to find the probability. So It's exactly the same as in the previous case when the distribution is standard normal, mean 0, standard deviation to 1, equal to 1. Right? So instead of 0 and 1, we put in the mean 50 and the standard deviation 35 into the function. Right? So again, very easy to calculate, and the answer which represent 4 decimal places, 0.4207. The second case, right? The first case is less than, the second case is more than, right? More than 67, so 67 is around here, right? So this is 60, this is 70, so 67 is around here. And what we're looking for the upper tail, right? So how do we find the upper tail? We will find the lower tail. The function always gives us the lower tail. 1 minus that function would give us the upper tail. So how do we enter it? We enter, say, 1 minus norm.dist, the point that we're looking for, 67, the mean is 50, the standard deviation is 35, and the function is 2. Okay, so again, that's the answer. Really, really simple. All right, so first case less than, second case more than, the third case is in between. We want to find the probability between 44 and 66. Well, 44 and 66, right? So 44 is around here. This is 40, this is 50. So 44 should be around here, right? And then 66, 60 is here, 70 is here. 66 is this part, right? It's this part. So we're looking for in between. So how do we find in between? The large area minus the small area, right? So by drawing a picture all the time, you can actually see what you're looking for. So how do we do that? We can just use the function twice, right? So norm.dist, the larger area, which is 66, comma 50 is the mean, the standard deviation is 35, and it's 2. Right? So that would give us the large area from 66 down, and then minus the small area from 44 down, right? So norm.dist, 44, comma 50, comma 35, comma 2. Okay, so that's the way that we can enter the difference between the two functions in order to calculate the probability. So again, if you format it to 4 decimal places, you now know how to do all 3 different cases: less than, more than, in between, to find probabilities for a normal distribution. The last 2 cases is about given the probability, find the point, right? So in the fourth case, we say find A if probability of x less than A is equal to 0.32. 0.32 meaning the area below, because less than meaning the area below. Again, if you draw a picture, what we're saying is that we are given this probability, right? The probability is 0.32. We want to find the point that corresponds to A, correspond to that probability, right? So how do we do that? Because we are given the lower tail. So what we have to do is use the function directly, the function that we learned before, equal sign norm.inv, right? So inv is given the probability, find the point, right? So the probability that is given to us is 0.32, and the mean is 50, and the standard deviation is 35. And so the point that we're looking for is 33.63, right? So if you keep it to 2 decimal points, that's what we're looking for. So the area is actually, the point that corresponds to it is actually here, right here. And you look reasonable, right? Because the mean is 50 and the area is 0.32, which is less than half. So our answer probably is right, below 50. On the other hand, the last case, we want to find B so that if probability of x bigger than B is 0.75, right? 0.75. Now, 0.75 is more than half. So the whole area is more than half, bigger than more than half. Right? Half is here, more than half. So the point that we're looking for should be around here somewhere, right? So we are given the upper tail. We want to find the point that corresponds to it. So in order for us to use the function, we have to convert the upper tail into lower tail, right? So just remember, in normal distribution, everything is about the lower tail. So if you're given the area of the upper tail, we have to find the size of the lower tail, the probability of the lower tail, and then use that function, right? So how do we do that? We say equal sign norm.inv, right? And instead of putting 0.75 into the function, we do 1 minus 0.75 because this is we're given upper tail and the function only taking the probability of the lower tail. So 1 minus 0.75. The mean is 50. The standard deviation is 35. And it's true. Oh, sorry, you don't have to enter true because this is not a distribution function. Okay, so that's all you have to enter. And bingo. Right, so the number that we're looking for is 26. This is a little bit more than we expected. Is 26.339. So again, if you know how to do all 5 cases, then you already know how to do everything about the normal probabilities. So that's it for this video. Hope that you enjoy it, and we'll talk to you again in a future video. Bye for now.